Today we are going to begin our conversation about transformations, and this is a theme that carries over throughout the entirety of Algebra 2, is talking about transformations from parent functions. So we're going to start with four really basic parent functions, and a parent function is the most basic form of a function. Every other function with the same shape or similar shape is based on transformations that have been done to the parent function. Now, this is not new. The one we're most familiar with already is a line. So the parent function for a linear function is f of x equals x or y equals x. But we know from what we've seen that we can change the m and we can change the b. So I can say negative 2x plus 5. That is a transformation on the parent function. I've moved the y-intercept and I've changed the steepness and the direction of the line by changing the slope. And so we're just going to take this a little bit more broad and a little bit more abstract to be able to talk about functions in general. So the four that we're looking at now are the constant function, that's a horizontal line, the linear function, f of x equals x, which makes a non-horizontal line, the absolute value function. Now, we've worked with absolute value, but not in the context of a graph. An absolute value function makes a V-shaped graph, and that's because, think about the graph of a line. All of these ordered pairs have a negative x and a negative y in this quadrant 3 here. But when I take the absolute value, then every x that I plug in, y is going to be equal to the absolute value of x when I do absolute value, which means any x that I plug in is going to turn into a positive y, so that whole side of the line ends up here. That's what gives it its V shape. So that's an absolute value. And then a quadratic, which you saw in Algebra 1, the parent function is y equals x squared, and that graph is called a parabola. Today we're going to talk about one type of transformation, which is a translation. But in general, transformations of a function are going to change the size, the shape, the position, or the orientation of a graph. So anything that doesn't match the parent function exactly is coming from a transformation, which is just a change to a parent function. Now, this is the key to understanding the whole thing. A parent function, any transformations done to a parent function can be classified as either horizontal or vertical. So anything that is happening horizontally is going to happen inside the parent function. It's going to happen inside parentheses underneath the squared, inside the absolute value bars, inside a square root symbol. We're going to get to all kinds of functions. Anything vertical is going to happen to the whole function, and that's going to change the output, which happens outside of the parent function, okay? So another way to think about this, horizontal transformations that happen just to the x, they change the input of the function, okay? Anything vertical that happens to the whole function, because it affects the whole function and not just the x, it's going to change the output of the parent function, okay? And so that's a thing to keep in mind. So I'll show you what we mean by inside versus outside when we look at this rule. So the first transformation we're going to talk about is a translation. So a translation does a slide of the graph. It's going to shift, in other words, the graph to the left or to the right. That would be horizontal. Or it's going to shift the graph up or down, which would be vertical. Now look at the rule, and this is the idea of inside and outside. The rule here for vertical is that I either add k or subtract k, and it's happening outside of the f of x. Versus, you see here horizontal, the minus h and the plus h is happening inside the function. It's f of x minus h. It's no longer just f of x, okay? Now, vertical and horizontal are always kind of backwards of each other. So if I say f of x plus k, that's going to shift my function up. F of x minus k is going to shift my function down. But horizontal is kind of always the weird one as a general rule. It's backwards of what we expect. So when I see f of x minus h, I want that to move to the left, but it's actually going to move it to the right. F of x plus h is going to move it to the left. And it's going to move it up, down, left, right, depending on the value of k or h. You'll shift that many units to the left or to the right. So here's a couple of examples of where it's happening outside of the function. Let's think about absolute value. I could say y equals the absolute value of x plus 2. That's going to take my absolute value V-shaped graph and shift it up 2. Or I could say something like y equals the absolute value of x squared minus 4. That's also happening after the squared. So that's going to move us down down 4. Horizontal is going to happen inside the bars or inside what's being squared. And so it'll look different. Horizontal would look like y equals the absolute value of x plus 2. See how the plus 2 is between the bars rather than after? And remember, this is backwards, so this is going to move our graph to the left 2. And then if it was quadratic, parentheses are really, really important here because now you can see it's happening under the squared, not after. And the minus 4 here is going to move us to the right 4. And so that's all we're practicing today is identifying that inside and outside and identifying if it's moving up or down or left or right, or maybe a combination of both. We'll see. So let's look at a couple of examples. The first thing that I would like you to do as a quick little check for understanding is put your video on pause and see if you can name each of these parent functions. So you need to recognize parent functions by their name, by their equation, and by their graph. So look back at the previous page if you need to. I'll come back with those answers in 3 seconds. Okay, the first one has the bars. That's an absolute value function. The second one, I noticed the squared. That tells me it's quadratic. The third one is just an x to the first power, so it is linear. Also, it doesn't have any absolute value bars. Now, because it has an x, it's linear and not constant. If it was just y equals a number, that would be linear. Number 4 is that U-shaped graph called a parabola, so that tells us it's quadratic. 5 is a line, that makes it linear. And 6 is that sharp V shape, which makes it absolute value. So now what I want you to do is see if you can identify the transformation that has been performed. You don't need to write an equation for the graphs. I just want you to say in words, did it go up 7? Did it go left 1? What is it that is happening? Make sure you're looking for insides versus outsides. And then on the graph, you just want to think what has changed from the original graph. So again, put your video on pause, see if you can try it yourself, and then come back here in 3 seconds for the answers. Okay, so in the equations, we need to look at what changed. So the parent function is just absolute value of x, but we added the plus 4 inside the bars. So that tells us it's horizontal because it's inside, and horizontal is always weird, so it goes to the left 4 when it's a plus. Number 2, that minus 5 is happening after the squared, so that's an outside, which makes it vertical, so we're going down 5. Now, number 3, and we can kind of think about number 5 also, linear is weird because it could be either. I could think of this as y equals x plus 1, and I say the plus 1 happens after y equals x, outside y equals x, so that moves it up 1. But if I were to write it like this, y equals x plus 1, that also looks like it goes to the left 1. Now, it is the same thing. Okay, so let's think, and I wouldn't add this onto your paper because it'll be confusing later, but I just want to show you. If we graph that line y equals x, just the parent function, which would be right here like this, okay? That's the parent function y equals x. If I move it up 1, that moves it to this line here, but notice what also happened. It also moved to the left 1. It does both. That's the only function where that happens, where they kind of do this 2 at the same time, okay? And that's just because of the shape of the graph. And then on number 4, 5, and 6, you just need to look at what happened. So we moved the quadratic to the left one. Normally its vertex is at 0, 0. Number 5, you could say right 2 or down 2. And number 6, we can see that that V moved up 4 units, okay? Now, this last example here is a little bit more abstract, so it's a little bit more general. It says the function graphed is f of x. Now, we don't know the equation for this function. We don't know. They're just saying, here's a picture of f of x. That's our parent function. It's not necessarily one of those 4. We can tell by the shape that it's not, but that is the graph that we have. It says state the transformations that have been performed on f of x and sketch the graph following the given transformations of f. So I look at A and I see f of x minus 2. That minus 2 is happening outside of the f of x, so that tells me it's vertical, and minus 2 means that I'm going down 2. So then to graph it, I'm just going to do that. I'm going to take each of these points and slide them down 2, down 2, down 2, and there is the transformation of my function f of x. So again, I'd like you to pause the video and try B. B has 2 transformations in it, so you're going to have to do both at the same time. So come back in 3 seconds to see the final answer. Got cut off by an announcement there. So inside the function is that plus 3. So that's going to be horizontal. That tells us it goes to the left 3. And we have outside the function that plus 1. So we're going up 1 also. And we can do both of those things at the same time. So again, to sketch this new graph, for each of these points, I'm going to go to the left 3 and up 1. Left 3, up 1. Left 3, up 1. Left 3, up 1. And that gives us the same shape. It's just been slid over to the left and slid up 1 unit. And so that's the idea with translations.